File system is a format in which data is stored. So the data is stored in the form of files, and then there are directories also. There are directories, subdirectories and all that. Okay. So there are different storage devices, like hard disk can be there, solid state drive can be there, DVDs are there, and they have their own file systems. Okay, so some file systems may be different for different storage devices, and some storage devices are there which support the same file system, like the file system used for hard disk may be used for SSDs but may not be used for DVDs. DVDs have different ways to store data and they have different file system. Okay, so it provides an interface to storage, and it maps logical address to physical address, and it also provides efficient and convenient access to disks. Okay, the input output data is performed in the form of blocks of sectors. Like in case of main memory, pages are there, pages, so the data is transferred in the form of pages. Okay, now here instead of pages, blocks of sectors are used. Okay, so a file is given some integer number of blocks of sectors. Like suppose there are 4 sectors in one block, so a file may get 1 block or 2 block or 3 block and so on. A file will not get half block. Okay, so just like process control block, there is file control block, and file system is organized into layers that we will see in the next slide. Users get a logical view how the data is stored in a system. Okay, like the data is stored in the form of files, and there are directories. A directory can contain files and subdirectories. Okay, so location of a file can be, like in case of Windows, it can be C drive or C:/ some folder, and that folder may contain some file. Okay, so and in Linux there is some absolute path given to a file or directory. So that is a logical view. This is the view that application programs also get and users also get. Okay, but devices will not understand these addresses. So the addresses generated, the logical address has to be converted to the addresses which devices will understand. Okay, and this is done in multiple layers. So the address is converted from one form to another form, then from second form to third form in this order. Okay, so logical file system generates some address that is converted to address understood by file organization module, and it also converts it, and that address is understood by basic file system. So it is converted in this form. So the details of this layered file system we will see in the coming slides. Device drivers directly interact with the hardware, and the hardware that we are talking about is storage device. Okay, so in case of hard disk, this is an example of a command: read drive 1 cylinder 72 track 2 sector 10 into memory location 1060. So the command contains the exact location from where reading has to be performed or writing has to be performed, and once it is performed, where should the data be stored? It should be brought to memory location. Okay, and then it converts this command into low level hardware specific command, so that is understood by the hardware. Okay, so command converted will be directly understood by the storage device. Basic file system handles simpler command like retrieve block 123. So it is in the form of blocks, that which block reading or writing has to be performed in which block, and it will be converted into a command that is understood by device drivers. Okay, basic file system also manages buffers and cache for improvement in performance. File organization modules translates logical block number to physical block number. So, and it also manages free space. File organization modules understands files, logical addresses, and physical blocks. Logical file system manages metadata information. Metadata is data that describes data. Okay, it translates file name into file number, file handed, location, etc. It does directory management, it handles protection. So these are all the layers. Layers have advantages and disadvantages. Advantages are that it reduces complexity and redundancy but adds overhead, and it decreases performance because of that. Okay, and there are many popular file systems like for CD-ROM, ISO is there, Unix has UFS, Windows has FAT32, NTFS is latest that is being used. Okay, Linux has ext2, ext3 file systems, ext4 also is there, and there are many new file systems which are coming. File system implementation. Okay, so how to implement file system? So a program can access file system using system calls. Okay, like open system call, close system call. So those system call facilities are provided to programs to access file system. A file system also contains boot control block, which contains booting information. So a hard disk is contained, it has a specific location which contains booting information. So if some OS has to be loaded, then initially that location has to be searched. Now that location will contain the location of the operating system to be loaded. Okay, and each volume is each partition, contains some details that includes number of blocks in that volume, number of free blocks, block size, and free block pointers or array. Okay, and there is directory structure that organizes files, and for each file there is file control block, like in case of processes, each process has process control block. The same way here, each file has a file control block that contains details like inode number, permissions, size, dates, etc. These are some of the contents of a file control block that contains file permissions, file dates, when was the file created, when was it accessed, when was the content written, so those dates, who is the owner, group, etc., size of the file, data blocks of that file. So a file contains some data and that data will be stored in blocks. So a file gets some integer number of blocks like 1 or 2 or 3 and so on blocks. Okay, so where are those blocks? The location of that blocks. A partition can be a volume that contains a file system, or it is without a file system. So if it is without a file system, it is called raw. Raw means it contains a sequence of blocks without any file system. Now boot volume points to a volume which contains operating system, or it points to bootloader set of blocks that contains enough code to know how to load the kernel from the file system. Okay. Root partition contains operating system, and there are other partitions which may contain operating systems. Some partitions may be mounted at boot, or some partitions may have to be manually mounted. Virtual file systems provide the same interface that is provided by a normal file system, but unlike a normal file system, it does not interact directly with the hardware. It interacts with the file system. Okay, so for example, that a file system might be mounted on a drive in case of Windows, or a folder. So when you are accessing that drive, you are writing something or reading from something, but that is actually being stored on a file, or maybe in a hard disk. Okay, so whatever you are reading or writing is actually being read or written to that file. Okay, a virtual file system provides some interface. The content may be read or written to a local file system or a remote file system, or the content may be distributed among different file systems. A directory contains subdirectory and files. Okay, and these are two ways to implement a directory. Like one way is a directory will contain linear list of file names, and each file name will have a pointer. It will point to the data block of that file. Okay, it is simple, but when the number of files become very large, then searching becomes difficult. So there is another implementation, hash table implementation, where linear list is there, but hash data structure is used. So this makes searching fast, but there can be collisions, like two file names has to the same location, and there are ways to handle collisions. In case of main memory, the memory is divided into frames, and each frame can contain one page. Okay, so page is the smallest unit of memory that can be allotted to a process. Okay, so if one process will get some integer number of pages. Now just the same thing is done here. A file will get some integer number of blocks based on its size. Okay, so if it has 0 size, it will have no block. If size is 1 byte, then it will get one complete block. Okay, so depending on the size of a file will get some set of blocks. So how should the blocks be stored? How these blocks are allotted to files? One of the allocation is contiguous allocation, means each file occupies contiguous blocks. So this has very good performance, but the problem is if the size grows, if a file grows, then it is difficult to find new blocks. New blocks may be available, but they may not be available on contiguous locations. Logical address is given by block number and displacement into block. Q is the block number and displacement into block is R. This slide shows directory structure. Okay, so in this example there are 5 files. They have starting block number, address and length. How many blocks are given to a file. So for example, count, it starts from block number 0 and its length is 2. So block number 0 and block number 1 are assigned to count. Similarly, mail, it starts from block number 19 and its length is 6. So 19, 20, 21, 22, 23, 24, these 6 blocks are assigned to mail. Okay, similarly, list starts with block number 28 and the length is 4, 28, 29, 30, 31. Okay, similarly for the same thing is for other files also. One problem with contiguous allocation is that when a large file has to be stored, then the space may be available, but that space may not be contiguous. Okay, another problem is that if the size of a file has to increase, then it may be possible that the next block may not be available. So if a file has 5 blocks, the 6th block may not be free. So now what to do? So these problems are handled by extent based system. So in extent based system, a file is given few extents, one or more extents, and each extent is contiguous block of disks. Okay, and many newer file system use this modified contiguous allocation scheme. Another allocation method is linked allocation. So this allocation is just like a linked list. So file pointer will have address of the first block. The first block will have address of the second block will have address of the third block, and so on. And last block will have address as null. Okay, so this will not have any external fragmentation because each available block can be used. If a free block is available, that free block can be used. Okay, and free space management system is called when a new block is needed. And efficiency can be improved by clustering of blocks. So if contiguous blocks are available, then they can be clustered. This can improve the efficiency, but the problem is that many times more input outputs have to be done. Like for example, if 5th block has to be accessed, the address of 5th block is stored in block number 4, address of 4th block is stored in block number 3, and so on. So accessing of 5th block requires accessing of all the initial blocks. Okay, so more input outputs are needed, and if suppose one address is wrong, then a lot of blocks information will be lost. So reliability can be a problem. This is an example. So in the directory structure, a file will point to starting of the block and end block. Okay, so the first block will have address of the second block, second will have address of the third block, and so on. So don't look at the number given inside these blocks. Okay, so like block number 9 points to block number 16, block number 16 points to block number 1. So in this way they point, and the last block is block number 25, it does not point to anything, and this is the last block. Another allocation method is index allocation. So there will be an index block which points to all the blocks of a file. Okay, so the index table is stored in an index block. This is an example of index allocation. The directory structure contains index block of each file. Okay, like the index block of file zip is 19. So block number 19 contains the location of each block of this file. So the first block is stored in block number 9. Okay, at the address of second block is block number 16, and so on. An advantage of index allocation is that it is suitable for random access. Okay, so suppose you want to access any block, then just first access the index block, and then index block will contain the address of that block, and then that block can be accessed. So as compared to the linked allocation, accessing a block requires accessing all the earlier blocks. That is not there with index allocation. So it is faster, but it needs an additional block, that is index block, that contains the index table. There are many advantages of different allocation methods. Like contiguous allocation is good for sequential and random access. Linked allocation is good for sequential, but it is not good for random access, because if you want to access any block, then all the previous block have to be accessed. But in case of sequential access, suppose you want to access block number 5 and you are currently at block number 4, then block number 4 contains the address of block number 5. So for sequential access it is easy. And based on the access type, appropriate allocation method can be chosen. And index allocation requires one additional block, but clustering can improve the throughput. Like suppose multiple blocks can be placed together. Okay, so they are clustered, they are grouped, and that grouping can improve the performance of index allocation. This slide compares the performance of disk input output speed and CPU speed. So objective is to reduce disk input output. Okay, because the time taken to do this one disk input output is very large. Now if adding few instructions to a program or to process is able to reduce disk input output, then it is desirable, because the time taken to execute those few instructions will be very less as compared to the time taken to perform one disk input output. Like in this example, suppose Intel Core i7 processor is used at 3.46 GHz, then on an average the number of instructions performed will be 630 million instructions are performed during one disk input output in case of hard disk, and 2.65 million instructions are performed during one disk input output in case of SSDs. So this means CPUs are significantly faster as compared to disks. So adding few instructions is preferred if this addition is able to reduce one disk input output. File system manages free space list to track which blocks are free or which are not free. Okay, so there is a bit vector or bit map that contains information for each block. If a block is free, then in that case the bit will be set as 1. If the block is occupied, then the bit will be set as 0. There will be a pointer to the free blocks, and this pointer must be protected, and similarly bitmap also should be protected. So bitmap must be kept on the disk. If it is in the main memory, then it will be deleted when the power goes off. And so a copy of bitmap can be brought to the main memory, but to ensure consistency, when something has to be modified, then first modification should be done in the disk. Then, like suppose a particular block's bit value has to be modified, the first modification should be done in the disk, then the block can be modified, and then after that the modifications will be there in the main memory. Bitmap requires some extra space. For example, if block size is 4 kilobytes, which is equal to 2 to the power 12 bytes, and the disk size is 1 terabyte, which is equal to 2 to the power 40 bytes, then the number of blocks is 2 to the power 40 divided by 2 to the power 12, which is 2 to the power 28. So these many bits are required. So the total memory required is 2 to the power, it is 256 megabytes. If clustering is done, means 4 blocks are combined into a cluster, then in that case 64 megabytes of memory is required. Now one another advantage is that using bitmap method, it will generate set of bits, so it is easy to get contiguous space. What are the contiguous blocks which are free? That is also easy in this case. Now another method that is used is linked list method. So there will be a linked list. So the first free block will have address of the next free block. The next free block will have address of the third free block, and so on. So it cannot get contiguous space easily, but there is no wastage of space. Okay, and there is no need to traverse the entire list if any block is free, because only the free blocks will be traversed. So you can see in this example that the first free block has address of the second free block has address of the third free block, and so on. Okay, and the last free block has null as address of the next block. It is just like a linked list. This is a modified method. So in this method also there is a linked list, but instead of pointing to next block, it points to next group of blocks which are free. Okay, so blocks are grouped and each group contains contiguous set of free blocks. Okay, so this means suppose there is one group which consists of block number 4, 5, 6, 7, and block number 8 is not free. So 4, 5, 6, 7 are free. Block number 3 is not free. Okay, so block number 4 will have a counter that next 3 blocks are free. So the counter will contain a value 3, that next 3 blocks are free, and it will have a pointer which points to the next group of free blocks. Okay, the next group of free blocks may be block number 17, 18, 19. Okay, so it will have a pointer to block number 17. Okay, so similarly block number 17 will have pointed to next group of free blocks. Okay, and it will also have a counter of how many contiguous blocks are free.